Okay, hopefully this video is going to help you with the stuff we're learning, this domain and range, set, and interval notation. Remember, period 7, if you go and look at my class document, I have two good examples of slides that I'm looking for. So yesterday's homework was 11.1, interval notation, set notation, domain, and range. So I have a student here who's got a video you're more than welcome to look at. Hopefully that's okay with that student. What I'd like you to do on these slides is spruce them up a little bit, label them, and get a picture. So hopefully you'll have time in class at some point to do that. So look at those. I got two good examples of students who made videos of them doing the work that we learned yesterday. So watch them. Good examples. Alright, so back to this. For this problem right here, number 1, sorry about the way I stapled it. I stapled it a little strange. So if you take that staple in the right hand corner, this is page number 1. So for this domain is measured left to right, looking at where it corresponds to the x-axis. So from here to here is my domain. So my domain for interval notation, when you use that bracket, it's going to be x is an element of, and then I go from left to right. Looks like from -3 on the x-axis. That's going to be less than or equal to because of that dot right there. Put my x in the middle. My other inequality is going to be the plain less than because of that open circle and where it lines up with the x-axis here at 4 and close that. So that is from -3 to 4. That is my domain. If I do that interval notation, square bracket -3, comma 2, rounded bracket 4, because that's an open circle right there. My range is measured bottom to top. So for set notation, I put a y right here. Y is an element of, and I look at where it corresponds with the y-axis. So from here on up, goes through the y-axis here at +4 up to 6. So I put a 4 right here, less than or equal to, the equal line in there because of that dot, put my x in the middle, a less than because of this open circle right here, up to 6. Close that. So that is from 4 up to 6. If I do interval notation, square bracket 4, comma, rounded bracket 6, from 4 to 6. That is my domain and range for that graph. Alright, next, I'll go a little bit faster. For this, my domain, x is an element of from -3, less than because of that inequality being open, to +2, and that's going to be less than or equal to in there. Sorry about that. Close bracket, close circle, so I put that line in there. So again, that is -3 less than x less than or equal to 2. For my set notation, interval notation, rounded bracket -3 to 2, square bracket. My range, measured from bottom to top, goes from square bracket -3, and sorry, I'm doing interval notation first, from -3 up to 2, rounded bracket. That is my range in interval notation. Set notation, put that y right there instead of x. That is a y, is an element of, and now I look at my y-axis from -3 on the y-axis to 2 on the x-axis. So from -3 less than or equal to, because of that solid circle right there, and a y right there in the middle, not an x, up to less than +2 on the y-axis. So again, domain measured from left to right on the x-axis. Range measured from bottom to top on the y-axis. Alright, next one, here we go. And we'll start moving with this concept of infinity arrows. A double. So my domain from left to right, x from, looks like -1, 2, 3, 4, 5, -5, less than or equal to, all the way over here to less than 2 because of that open circle. From -5 to 2, closed circle to an open circle. That would be square bracket -5 to 2, rounded bracket. For my range, bottom to top, put my y there. Now I look at the y-axis from -1 up to 3 on the y-axis. So -1 less than or equal to, because of that circle, y less than 3 on that y-axis from -1 up to 3, and I'm going to make sure I put that there because that is closed circle up there from -1 to 3. If I use my interval notation, square bracket, -1 to 3, another square bracket. Alright, infinity arrows, here we go. So my domain goes from x, from 3 on the x-axis is my left boundary, less than or equal to, but my right boundary is less than or equal to, I'm not sure which one, less than or equal to, but that's going to be infinity because that is going off to the right. There is no right boundary to that. So for interval notation, that would be square bracket on the 3 because that's right here, solid circle, to infinity, rounded bracket, and notice the symbol on that infinity is positive because that is going off to the right. Domain is measured left to right. Doesn't matter if that arrow is going up or down like this, it still has that left to right component, positive infinity going left to right. Even if this arrow is going down, my domain would still be measured as positive infinity left to right. Now my range, y, from +2 on the y-axis, less than or equal to because of the circle, y, to less than or equal to positive infinity because there is no up boundary. This is going up. Range is measured up or down, so it doesn't matter if this arrow is going this way or this way. That is a positive infinity range because that up or down component, even if the arrow is going off this way, is going up. That is a tough concept there. My interval notation would be from square bracket 2 to positive infinity. Infinity always gets a rounded bracket, just like a open circle. It's not included. You got to put a rounded bracket. You can't measure infinity there. So I'm sure I got to double check about that, whether that's going to be less than or equal to. That might just be plain old less than right there, but I'll double check. All right, next page. Here we go. Page number 2. If you flip it over, this is page number 2. So here we go, where it gets tougher. This, if I flip it around the way it should be like this. I'm sorry again. That is page number 2. Looks like this. All right. Domain measure from left to right. So even though this arrow is going down, it is going left to right, positive infinity. That is a tough concept. So for this, my set notation x, put a line there, from -3, less than or equal to x, to positive infinity. And yes, that is positive. Even though this is going down, domain's measured left to right. So this is going off to the right, even though it's going down here. So don't be faked out. Don't put a negative symbol there. Positive infinity. If I do interval notation from -3, positive infinity rounded. From -3, positive infinity. That is my domain. My range for this one, put a bracket there, y, measured from a negative infinity. There's no bottom limit to it. So range is measured from bottom to top. So even though this is going off to the right, to the positive zone, it is, in terms of being measured up or down, going down. So this is measured by negative infinity, less than or equal to y, bordered by right here, less than or equal to, because of that solid circle, +4. That is my range. If I wrote that, interval notation would be rounded negative infinity because there's no bottom boundary, and it is negative because it's going down, even though this is going off to the right, down, bordered by 4 square bracket. And again, this gets tough. I will help you more with these, I promise. All right, this one, my domain, measure left to right, goes off to negative infinity. Even though this is going up, it's measured left to right domain. So this is going off to the left. So that's the left border is negative infinity there, less than or equal to x. And then I go to the right here, positive 3, less than or equal to inside there. Sorry about that. So I'll rewrite that as negative infinity less than or equal to x less than or equal to 3. That is my set notation. If I did that, interval notation would be rounded bracket negative infinity to square bracket 3. Measure from left to right, negative infinity to 3. If I did my range measure from bottom to top. So I do have a definite bottom there, so I'm going to put y as positive 1 less than or equal to y less than or equal to positive infinity. Even though this is going to the left here to the negative zone of the graph, range is measured from bottom to top, so it is going up even though it's going off to the left. Measure from bottom to top, positive infinity. We'll practice these, I promise. For interval notation would be square bracket 1 to infinity, rounded bracket from bottom to top. Alright, these get tough. We will practice. Alright, next, this one. Domain would be x. Negative infinity going off to the left is the left boundary. That'd be less than or equal to x to positive 3 right there. Less than or equal to, because of that solid circle. If I did that, interval notation would be rounded bracket negative infinity to square bracket 3. Range would be from y to negative infinity, no boundary to the bottom there, less than or equal to y, up to 4, less than or equal to inside there. Sorry about that again. And if I did that in interval notation, that would be rounded bracket negative infinity to square bracket 4. Again, these all matter: negative, positive, rounded, squared. We will practice all of that. I promise it makes a difference to get these right. They have to be exact, either rounded or negative, or rounded or squared. You need to know exactly. Alright, last one for this. My domain, x. And I'm going to stop right there. Good luck.